Right, so imagine you're building a web application that collects user information through a registration form. This is a very common scenario for almost every software out there where you'd be required to input details like your name, email address, password, and date of birth. While this seems straightforward, ensuring that the data entered is valid and is of a specific format is a critical challenge. You do not want incorrectly formatted emails in your database or different date formats for birth dates entered by the user. You would also want to enforce a user to enter a password with certain rules to make them more secure. This user data can also be used in the future to integrate with other services, which is why you would ideally want the data that comes in to be in a consistent format. So my point is, data has to be clean for security reasons and also for future integrations. And to keep it that way, it has to be validated against a certain set of rules. This is where data validation becomes crucial, and just like everything else in programming, there's again a bunch of ways through which you can validate your data. We'll be looking at a popular library called Zord that streamlines this entire process and also provides a bunch of additional features. Now you might think that Typescript also does type checking. We can add some manual validation logic along with Typescript's type safety and get the same result, right? Sure, you can, but when we take a look at some examples, you'll see how easy it becomes to add different validators to your input data. And by the way, Zord is not specifically used to validate just input data. Any data that you work with in your application that can only be validated at runtime and not compile time, Zord can help you validate it. So think of an API response. TypeScript would never come to know what data you get from an API response. You can read the docs and define the type for the response, but TypeScript won't throw an error during compilation. Only when you actually get the data and it has a few missing properties will you get the error. That will happen when your app is actually running, which means this happens in runtime and not during compilation. So you can validate that data at runtime using Zord and gracefully handle that error in multiple ways. So all in all, for runtime validation, you'd need something like Zord. Enough talk, let's actually look at some code. Inside this directory, I'll create a simple React app with TypeScript using Vite. Let's also install all the dependencies. Okay, now that our React project is set up, let me also install Zord. Now when you use Zord, the typical flow looks like this. You first create a schema for the data you want to validate. The schema is just a set of rules that the data needs to follow. So let's create a simple schema of our own. I'll go inside the source directory and inside my app.tsx. Let me just create a simple schema. I'll call it name schema. And I'll be using the string validator from Zord. So let me first import Zord. Now this schema is used to validate an actual username. There's this method called parse that you can run on this schema. The method takes in the actual value as a parameter. So say for instance, I'm passing in my name. The name is going to be passed inside this parse method's parameter. And if the value matches the validator from this schema, so if it actually is a string, then it's all good. Zord expected it to be a string and it is a string, so we won't really get an error. But if that's not the case, then we will get an error. So let's look at that. I'll simply use this schema and run the parse method on it. Let me just add John for now. I'll save this and I'll run this project. So inside the console here, you don't really see anything, which means Zord has validated the string input against the schema successfully. But now if I change the value to something else, so if I convert this into a number, and if I go back to the browser, you'll see that we get an error, and this is a Zord error. It will actually tell you what exactly is wrong with the value that you passed in as a parameter. So it expected a string, but it got a number. So yeah, Zord has a very readable error structure, which makes it even more easier for you to debug any errors that you get during runtime. Now there are a few instances where you'd not want your application to just completely break if there's a mismatch in the data. So you can put this inside a try-catch block. So this section here, if you put it inside a try-catch block and you handle the error inside the catch block, the application at least would not break. But there is a more convenient way of handling this, which is by using the save parse method. So if I just convert this into save parse and go back to the browser, now you'll see that our app is not breaking, and this error was from the previous instance. So let me just reload this, and you don't even see anything in the console. Actually, let me go back here and try to console log this save parse statement. Here you will see that we get this object in the console. It actually tells you inside this error block that it was expecting a string, but it got a number. So whatever error you were getting in the parse method, you get the same error here, but it's not really breaking the application, it's handling it more gracefully. And you can use this object to maybe show a custom UI of your own that in some way tells the user that there's a mismatch in the data that's being expected versus what your application is getting. If I turn this back into a string, you'll again get an object, yes, but this time you won't really have an error block. Since this string adhered to the Zod schema, we get this structure returned from the save parse method. Now, just like a string, you can have similar schemas for the rest of the primitives. I'll put all of them on the screen here. I don't really want to go into detail for all of these types. It's pretty straightforward, to be honest. And if you want like specific validations for these primitives, you can go to the Zod documentation. But the true fun begins when you start to build complex object types on top of these primitives. So let's take this form as an example. It kind of looks complicated, but it's really not. So let's just quickly go through it. At the top here, you have the initial data for your form. Similar to that, I have an error state here. This handle change function will track input changes for each of these fields. Handle submit is a callback for the actual form submit. And you have your typical form structure in the form of JSX here. I also have a few styles in place here inside the app.css file and the index file. The repository link is mentioned in the description. You can get these styles from that repository itself. And let me just show you how it looks like in the browser. Yeah, so this is what it looks like. I have all these form fields and a submit button here. Now let's add some validation to this form with the help of Zod. So just like we created a schema for the string primitive in our previous example, we can also do the same for objects. Let's call our schema registration schema, and this will be of type object. Inside we'll pass schemas for individual fields. So I have these main 4 fields and an address block which has its own set of fields. And you can see here that I'm trying to inject a schema inside this schema. So that is also possible with Zod. You can nest schemas. So I'll have to create an address schema as well. Let me do that here at the top. Now, if you take a look at the validators for each of these fields, it's pretty straightforward what each of them is trying to achieve. So in the case of username, you have a string validator, and you also have a validator that restricts the username to not be less than 3 characters. If that is the case though, then you get this error message. Similarly, for email, you have an email validator that actually parses this email against a regular expression behind the scenes. And if the email is not of a valid type, then you'll get this error. Similarly, for password, you again have a minimum character validation. And in this case, if the password has less than 6 characters, then you'll get this error. And finally, for the age schema, you have a number validator. And you again have a minimum age validator here, which I have set to 0 for now. So anything below 0 is not valid, and you'll get this error when that happens. You have this address schema here. It has 3 fields: the street, the city, and the postal code. Street again is supposed to be a string, and there is a character limit. I've set it to 1 for now. So since I have a character limit here, this field is not really an optional field. The user has to enter something inside this field before they proceed to submitting the form. Similarly, for city, I also have a validator here, again the same validator. And for postal code, I have a regular expression. So you can actually create your own expressions. And if the data that's passed to the schema does not adhere to this expression, then this is the error code that you'll get. Now these schemas will solve your runtime type checks, but we'll still need Typescript to do compile time type checking. And if you notice, these schemas actually kind of look like types from Typescript. Username, email, password, all these fields are of type string. Address is of type address. We'll ideally have a different type for address. If only there was a way of using these schemas to directly create types without manually rewriting them. Well, there is a way. Zord has an infer method that figures out the type from the schema. All you have to do is use the infer method and pass the type of the schema, and that should do it. So infer actually lets you create a TypeScript type from a Zord schema. And if you take a look at this address type, it's exactly what we wanted. And similarly, the registration type is also what we'd expect it to be. So this is actually a very convenient tool when you're using Zord and TypeScript together. Now I can use this type for my state to provide more strict type checking. So in case of this form data, I can use the registration type. Okay, so now we have the schemas and the types ready. Now to perform validation, let's open up the handle submit function. Inside the try block, before making the registration API request, we'll have to validate the form input. Whatever values the user has entered inside the form, we'll need to validate it before we actually send it to the backend. I'll use the parse function here because I want to catch the errors and use it to display relevant error messages. So inside this method, I'll pass in the form data. Now the reason why I'm doing this here is because all the input fields essentially play with strings behind the scenes. So the age that we get from the form data will also be of type string, but that is not what we want on the backend. We want the age to be a number. I'm just converting the string type for the age property into a number. If the data matches the schema, we'll perform the backend operation. So this line will execute if the data matches the schema. But if there's an error, we'll need to handle it gracefully in the UI by showing the user some specific errors. So inside my error block, I'm first creating a validation errors object, and I iterate through each of the errors inside this error object. I convert them into a format that I want so that I can use it inside my JSX. So yeah, that is what I do, and eventually I set it to the error state. This error looks like it does not know the type of the error object. So what I'll do is I'll just check if the type of the error, whether it's an instance of the Zord error, because I only want this to happen when the error is actually an instance of Zord error, because this try block will also have an API request here. And if the API fails for whatever reason, then it's again going to go inside this catch block. And I don't want to do any of this if it's actually an API error. I only want this to execute if and only if the error is related to Zord. If that is the case, only then execute this block. So I can move this entire part inside this if condition, and that should ideally get rid of all the errors. And this should do it. Now if I go back to the browser, I should ideally get the error messages for each field. If I try to submit this form without filling any of these fields, you should see error messages for each field, and these are specific error messages that we had set inside the schema. So this means that our Zord validator works. Now if I fix this by typing in something, you'll see that the error message does not go away. That's because we have wired it to the handle submit function. We haven't really changed the handle change function, which actually triggers whenever I add something to this field. So since that is not when the validator gets triggered, this will only work when I submit the form. If I click on submit, this error message goes away. So yeah, that is one more challenge that we need to resolve. But to do that, there's a lot of additional logic that you would need to add to the handle change function. There'll be a bunch of edge cases that you'd have to keep in mind, which sure you can handle manually, but there are better ways to do it. If you notice, I have this another form component here, which looks a lot smaller than the one that we just built. But if I run it side by side inside the browser, if I click on submit on the first form and the second form, I get the same error messages for the fields that are invalid. Now if I try to update this street name here, let's just enter some random string, you'll see that this error is still here. If I click on submit, this error will disappear. That's because, as I had mentioned earlier, the validator is actually hooked to the handle submit method. So anytime I click on the submit button, only then will this validator work. So we don't really see the error message right next to this field. But in the case of the second form, if I try to change something here, and even before clicking the submit button, you'll see that the error message disappears. The validator is actually hooked to the change event behind the scenes. In the case of the second form, I'm handling it with the help of another popular library called React Hook Form. So if you see here, I have this use form hook being imported from React Hook Form. I'm kind of going on a tangent here because you don't really need React Hook Form to use Zord, obviously. But what I want to show here is the compatibility that Zord has with other libraries. Inside this React Hook Form, we again have the same Zord schemas and types for the registration form. We use the use form hook provided by React Hook Form and pass a resolver custom to Zord with the registration schema as the parameter. This resolver is responsible for integrating the Zord schema to this form. It also exposes some useful properties and methods like these three. The register method is used to connect input elements to React Hook Form's internal state management and validation. The moment you call the register method inside an input tag, almost 90% of the use cases are handled for you out of the box. It's that convenient. The handle submit method can be used as a callback function that runs when you submit the form. The errors object present on this form state object gives you error messages specific to the fields from the Zord schema. So you get this simple, consistent, easy to read form component with validation out of the box, which just makes things a lot more easier. But again, this does not have anything to do with Zord. It's just a great helper to improve the overall dev experience. Okay, now that we have looked at a good real world example, let's go back to some more interesting features that Zord has to offer. So in the previous example, we saw the Zord validator validating the data that was provided to it by the user, but it did not really manipulate the data in any way. It can though. So in instances where you'd want to change the type of a piece of data, you can use coercion. For example, say you have an input numbers field. Now all inputs at the end of the day will give you the values as strings, even if it's of type number. That's also the reason why in the first form here, we were converting the value of the age field before passing it to the API request. This right here is also coercion. It's not a Zord concept by any means. You can very well do it in JavaScript, but Zord also lets you do it. So in this example itself, let's change this logic. We have this console log statement here after this line, which will show us the object structure, and we want to specifically see the type of this age key. So let's go back to the browser and I'll open up the console. In this first form, I'll just enter the value of my age. Let's set it to 21 and I'll submit. I'll actually have to fill in all the fields and only then will I get that console log message. So let's try it now. This has to be a number. Yeah, you get this console log message, and if you take a look at the type of this age key, it's a number. That is because we did coerce it into a number on this line here. But now, instead of handling it here, we'll handle it inside the schema. So we actually don't really need this here, and we don't even have to spread our form data anymore. So this should look a lot simpler now. This is what the parse function now should look like, and inside the schema, I'll just add coerce before number. That way, I'm telling Zord to convert it into a number even if the data is of the type string. So if I go back to the browser now and try to submit this form again, you should see the same type here, even though we have removed the manual coercion that we were doing inside the parse data. But now we are handling the same thing inside this Zord schema. So that's how you would coerce your primitives in Zord. Behind the scenes, it's actually doing the same thing. You should be a little cautious when using conversion with booleans though, as any truthy value would also be converted into true and any falsy value would be converted into false. Now we looked at primitives and objects and their respective schemas, but you'll also come across situations wherein a variable would only accept a specific set of values. Say for instance you have a menu, and based on the menu key, you want to display some content. Now this menu key would for sure be a string, but it would be better if we are able to double down on what exact strings we will be using. So in the case of a portfolio website, for instance, you normally have an about section, a contact section, a portfolio section, an experience section. All these 4 strings would be the possible set of values for a menu schema. That's when you'd use an enum. Zord enums are used to define a set of named constant values. They are useful when you have a fixed set of values that a variable can take. There's another scenario which is somewhat similar to this example, but instead of literal values, it takes a bunch of types and expects the variable to be of any one of the types. This is called a union schema, which will basically test the input against each of the types in order and return the first value that validates successfully. One more very common scenario is when you don't know whether you'll get the data or not. So for instance, the form that we have inside the address schema, maybe the street and the city are not required. Just the postal code is what's mandatory. The current implementation won't let you submit the form without filling in the street and the city. So we somehow need to tell Zord that these fields can be optional. It's super simple to do that, by the way. All I have to do is append the optional method and that should do it. So inside this address schema, I'll remove this validator now, because since we are expecting it to be optional, there is no need to have a minimum character limit here. So I just replace it with optional and I'll do the same thing for the street field. If I save this and go back to the browser, now when I try to submit this form 1, the form on the left, and let me get rid of these values inside the street and the city field. When I click on submit, you'll see that we don't really get any errors below both of these fields. That's because we have made both the fields optional. So now the Zord validator expects a string value for both of these fields. But if there's nothing provided to them, then also it's valid because we have the optional validator. A similar use case is when you expect a variable to have a type, say for example a string, or it could also be null. Now you can use a union here and say that it can either be a string or a null value. But an easier way would be to use the nullable method. It's much more readable and less verbose when compared to a structure that you'd create using the union schema. Now in our form example, you won't really face that problem because you can't really send null values through a form. But Zord is also commonly used to validate API responses, and there's a very high chance that you get a null value in one of your API response objects. So that's when nullables come into play. You also have the nullish option that checks for null and undefined together, but that again is very unlikely to happen. You either would not have the key at all, or it would be present but its value would be null, which can be handled by chaining optional and nullable. So yeah, nullish also exists, but you most likely may never come across a use case. Now for all the primitives, you can go and check out the docs for additional validations. It's pretty straightforward and the docs have covered the most common use cases out there. In case of objects though, there are a few helpers and utilities that can make you more efficient. Let's quickly speed run through them. So if you have an already existing schema, you can extend from this schema just like you can do in Typescript. But by doing this, make sure that you have different keys in both these schemas. If there are keys with the same name, it will be overwritten. There are 2 ways to achieve this extend feature. We can actually use the extend method, or we can also use the merge method. Again, inspired by Typescript, you have an option to either specifically pick or omit a certain set of keys from an existing schema and create a new one out of it. This is something that I use quite often. So yeah, it's a very handy utility. If you worked with partials in Typescript, you also have a similar method in Zord that lets you make all the properties optional. The deep partial method is similar to partial, but as the name suggests, It's applied to all the levels in an object. Also, when you create an object schema and parse an object through the schema with some extra keys that are not part of the schema, Zord just ignores it and only validates the keys that were inside that object schema. You can make this more stricter by passing the strict method. That way, when you're parsing the schema and you get an extra key, Zord will throw an error. If at all you know that there will be unknown keys dynamically added to your object and you also know their types, you can use this catch-all method to validate any additional unknown keys across a type. But if you use catch-all, strict will become redundant because now you are telling Zord the types of all the known keys and the unknown keys. So all the keys are technically considered as known if you use this catch-all method in your schema. So yeah, these were some common object utilities that you can use in your schemas. Just like an object, you also have this other schema type called a record. In case of an object, you know the structure, meaning you know there will be keys called first name, last name, and email of type string, age, and type number. So you have the structure with you in case of an object. In case of a record though, you normally do not have the structure, as in you don't have the exact key names, but you know what it will look like. There are a few other non-primitive schemas that you can use. Let's quickly go through them. Arrays and tuples are similar schema types, but the core difference between them is that a tuple will have a fixed number of elements and can be of different types. Array also can have different types, but normally you would come across an array of a single type. Then you have promises. You'll pass the value of the returned object from the then method inside the promise schema. To handle the validation errors, we can use the catch method of the promise. Functions are again a pretty common one. You can pass the arguments method to validate the type of arguments. You can also do the same with the return type. You can also extract both of these types to use it somewhere else. That's the best part that I like about Zord. The idea is to repeat things as little as possible. You can refer to these schemas, create types out of these schemas, and in general move things around to avoid repetition. So yeah, that's pretty much all that I use from Zord in my React/TypeScript projects. Obviously, there are a few advanced topics like transforms and refinements that give you additional functionality to play with the data that you are parsing, but I don't really use them quite often. The point of this crash course was to cover almost 90% of the common use cases that you'd come across in your React apps. But as I had mentioned already, I would definitely recommend you to go through the docs once. There are a bunch of utilities for each data type that you can use for your own applications. Apart from that, if you have any other doubts or suggestions, do let me know in the comments and I'll try my best to address them. Also do subscribe to the channel and I'll see you in the next one.